Good morning. My name is Joris Blaton, and I'm technical trainer for FLIR Intelligent Transportation Systems. And the topic for this webinar is traffic data. The goal of this webinar is to present you with all the types of data that FLIR Intelligent Transportation has to offer, and also the solutions we offer for these types of traffic data collection. So what I did is I divided this webinar into three major sections. The first part, I'm going to talk about three different types of architectures in how you can collect traffic data. I will also name the different types of data and tell you what solutions that we offer that will give you that data. And there will be also a Q&A session. The thing is, although I'm put them here nicely in one row, it will be a little bit mixed. So I will give you an architecture. For that architecture, I will present the data and its solutions right away. So it's not going to be three major different sections, but they will be a little bit more intertwined. Anyway, the first thing that I want to present to you are the major architectures. The first type of architecture, I call it the pulse architecture. And what I mean with that is that you will have installed one of our sensors, a thermal sensor, a visual sensor, maybe a hybrid sensor. But in this case, it will be either a visual or a thermal sensor out there that will look at a vehicle, a pedestrian, a bicycle, and the moment that it detects that vehicle, pedestrian or bicycle, a pulse will be sent to a traffic controller. So each time there is a vehicle, pedestrian, each time that vehicle is being detected, a pulse is generated. And the number of pulses corresponds with the number of vehicles, pedestrians, and the length will correspond with the occupancy of that particular zone. So that's the first one. The second one that I want to go more in detail is what I call the architecture where we collect data. In the same way, these sensors, visual or thermal, in this case also a possible hybrid, again, they're looking at your road, at your area where you want to detect bicycles, vehicles, or pedestrians. But now that data stream can either be collected on the device itself, and then you download it on a laptop, on a desktop, and you can access it as a user. Or you can even go a step further, you're collecting it on a server, and you have direct contact to it over a cloud or over web browser. So it's in your own domain that you use that or have access to that collected data. It's even possible that, in fact, that an end user, an operator, or you is not working directly on the server that has the data collected. No, there's an in-between system and you have access that data through that in-between system. So that's the collection architecture. And the third one that I want to focus on and give you more detailed on the solutions and on the type of data that we collect over there is what I called the connected architecture. And this connected architecture is not anymore about one location, one particular point where you collect data. No, like in the previous one, so in the pulse, it's one point, with the collected, it's one point. No, here we're talking about, we have multiple points where we collect data. And what we're going to do is we're going to grab the data that is being, no, I'm sorry, we're not going to grab the data. We're going to grab information from a vehicle through Wi-Fi and use that Wi-Fi to send that Wi-Fi signal towards a cloud solution. And in the cloud solution, with that Wi-Fi, we know more about what is happening between these different points. So it's not anymore data about one particular place. No, in this case, in the connected architecture, it's about what happens between places. And that's, yeah, because we use information from connected devices. About each of these, I will go more in detail, because the types of data that I want to discuss and to present to you, the ones that we have, are the following. We have data purely vehicle counting. We have also what we call vehicle presence data. We have bicycle counting and what we call bicycle data or bicycle presence data. We have pedestrian counting, we have pedestrian data. We have traffic data. We have flow data, premium traffic data, and high resolution real-time traffic information. So all different types of data. Let me explain each of them one by one. And the first is in fact a group of data that look quite similar. Vehicle counting, bicycle counting, and pedestrian counting. Why do I call them similar? Because they are in fact linked to the architecture, to my pulse architecture. In this case, what we have a sensor out there, a visual sensor or thermal sensor, detecting the vehicle, the pedestrian, the bicycle, and the moment that we detect it, there's a pulse being generated. And it's the controller that uses in one way or the other that pulse. Let's look at the first one. The first one is about bicycle counting. And what are we going to do within bicycle counting? We are going to put vehicle presence zones out there in what we call a loop mode. So each time a vehicle is driving through these loops, so each time the vehicle enters and exits the loop, a pulse is being generated. And the number of pulses corresponds to the number of vehicles. And the length of the pulse indicates the zone occupancy. And just to show you with an example here, so the moment that a vehicle enters the loop, so that's the middle section, we have a pulse. Here the vehicle is standing in there, so we know also the occupancy. And it's only going to be here in the loop mode because that allows us to give an accurate count of the number of vehicles. So we have a pulse, we have a contact closure, and the controller uses in one way or the other that particular pulse. These are examples about vehicle counting. Now, which devices are able to do this vehicle counting? What are the solutions? First of all, we have our traffic cam. The second is our traffic cam extreme. So traffic cam extreme, both visual sensors. And then we have two thermal sensors. That is possible. It's also possible with the thermic cam and the thermic cam 2. So both we can use for vehicle counting using the pulses. It's not only about vehicles, it's also about those special vehicles with two wheels, bicycle countings. Again, the same thing. You see again here on the image a loop. In fact, it's a double loop. We have superposed two loops, one that is going away from the camera and one is approaching. So we want to detect in this case, or count in this case, cyclists going away and cyclists approaching. And so also here a pulse is generated each time, and here it's not when it's enter and exits. Here a pulse is generated when when in this case the bicycle is exiting the loop. Then a pulse is generated. Let's take a look at an example that we have here. Here we have again the example of two loops because we want to do a detection in two directions. Notice at the end, close to the arrow, where you see that we have three wires in this example, and these are we call tripwires. So the moment a cyclist crosses these wires, we will have detection. This is still the current bicycle count. You will see in future projects that the three wires are gone, but it's still the moment that a cyclist is exiting the zone. So just showing you, vehicle enters, and notice the number changing each time a cyclist is exiting. So here you can use a pulse for your counting, and maybe you want, and I think in this example we use that. There's a kind of counter out there that tells exactly to the cyclists on that particular road how many cyclists are there. So each time a cyclist passes through these loops, the number goes up. It's not only possible with, first, before I go to the next one, which products can do so? Thermicam and Thermicam 2 both have the bicycle detection on board, so both of these devices can do the bicycle counting. One thing that I already want to point out, maybe some of you already experimented with Thermicam 2 and the bicycle. There you will notice that the zone will look a little bit different. We don't have the arrow anymore, and the zone is now capable of doing it just with one zone, doing in both directions. But the principle remains the same. The moment that a cyclist exits the row, we will have, or you have the possibility to activate a pulse to close contact. The next one is, and it's quite brand new, or it's coming up, pedestrian counting. So as from next year, beginning of the first quarter, we will be able to give to you on some of our solutions the possibility to count pedestrians. And how will it be? Well, what you will have is, for instance, you have here a crossing, you have an area where you want to do the detection. And the moment that a pedestrian enters this zone and exits the zone, and mostly when it exits the zone, you will have a pulse. You can even make the zone direction sensitive. So if I would have made that zone direction sensitive in the direction of the crossing, only pedestrians walking in that direction would be counted. So pedestrians from the other side would not be counted, wouldn't get a pulse. So there's only going to be a pulse the moment that that pedestrian is going in the direction of the arrow, of the direction sensitivity arrow. Which devices will be able to do so? That is going to be possible with our ThreatView 1, and our Thermicam 2 will be able to do that counting bit. Yep. So these were the different types of traffic data, and it's all about counting, vehicle counting, bicycle counting, pedestrian counting, but in a way that they generate pulses. So it's about pulsing. Before I go and get to the other types of data, and also the more detailed, the other architectures, are there from your part already some questions that you want to ask me more specific about this architecture and those types of data collection? The next set of data that I want to focus on is the vehicle presence data, or the vehicle data, the bicycle data, pedestrian data. We have also traffic data, flow data, and what we call premium traffic data. Now, all this data here, in this case, is linked to the architecture that I call the collect architecture. And what I mean, just rephrasing the collect architecture, what is happening over there, three different ways. Either your device is collecting and storing the information on the device itself, and depending on the height and depending on the number of lanes and the traffic, you can keep that data for a period of time on that device. And then you can connect your laptop to it and you can download it from the laptop. Or your device is connected to the network, your network, the network of your customer. And then with software, you can subscribe to it, you download it on a server, and you have access to it, you have access to the data on the server. Or we have an extension to that particular scenario, to that second scenario, is that there is an in-between system that gathers that information from the server and maybe presents it in a more suitable way than it was stored on the server and presents that to an operator. Anyway, in this scenario with this architecture, what we have over there is we use an API. The data comes in as an XML stream and is stored as data on the device, on your server, on a laptop. It's not anymore about pulses. No, it's about a data stream that you're going to collect on a device or on your own network. So it's your private network. And then through different tools, you can access it. And what can be these tools? Well, you could use a free tool from FLIR ITS that is called the Trafficon download tool. And it allows you to download in a particular format that we already made for you. In a particular format, you can download that information. But not only that, there's also the possibility that you want to create your own type of download tool, or you want to download specific data and the other ones, there is no interest of you, then you can subscribe yourself to the API. And how can you do that with to the API? Well, each of these devices have an IP address, just the IP address /API, and you have a complete subscription, complete description of how that API and how you can subscribe to that. Or there is also the possibility that we have our, what we call our Flux server database, that you have that in place and that data is stored in Flux, being collected in Flux, and then you have all kinds of reporting tools over there. So that is the data that can be collected through that type of architecture. And what are these data? Well, let's go a little bit more in detail. Data that you could use, and you're going to use that same loops that we saw earlier for the pulses. You could also listen to the API of certain devices, and then what you can get out of that information is not anymore as a pulse, but now as part of the API as an XML. You can find out how many vehicles have been counted by that loop and what is the zone occupancy. So now it comes as data, not anymore as pulses. So if I show you again with an example, here we have vehicles being again counted. You could use pulses, but you could also subscribe to the API and get information on a server of how many cars are being counted by these loops and what is maybe the occupancy of these loops. This type of data can only be collected by devices that are Ethernet devices. So these are the ones that can collect that. It can be done with a Trafficam Extreme. with the Thermicam and the Thermicam 2. So these three devices can collect this type of vehicle presence data. Then we have the bicycle presence data. And you say, oh, it's the same kind of loop. Yes, it's the same kind of loop. And instead here, it's the same idea as what we saw with the vehicle presence data. The idea is here the same. You're not going to use the pulses, but the data collected by the device, by the solution. And here an example. So what is happening here? And you see here the cyclist in there. So the moment that the cyclists are in there, we put a plus on it. So in that moment, we know them that this information is in there. One thing that you have to know, and it's also with vehicle presence data, here we talk about integration interval. So this data, you specify an integration interval, 10 seconds, 20 seconds, 60 seconds, 3 minutes, 6 minutes, whatever you like. And the data will be collected based on that integration interval. This information, this data can be collected by the two devices that are capable of bicycle detection, that is the Thermicam and the Thermicam 2. Also, again, from Q1 in 2019, the pedestrian presence data will be possible. So instead of using the pulses, the XML information about occupancy and about the counting can be collected with the following devices. That is the Thermicam, Thermicam 2, and the Trafi 1, certainly the Trafi 1, because that's the device for pedestrian detection. It will be able to collect that presence data. Then we have the traffic data. Traffic data, in that case, what you will do is here with traffic data, because with traffic data, and I will show you what I mean with traffic data, there's a little bit more specificity on how you going to install your camera. So there the height will be quite important, but for sure also the angle to detect traffic data. And we prefer that you position it at an angle of about 45 degrees. And normally the detection will start at about 6 meters high and higher, depending on the number of lanes on which you want to do traffic data detection. And with traffic data, what I mean with traffic data, well, it's first of all integrated data. So again, you specify the integration interval starting from 10 seconds to, I think in total, half an hour, and in between you have 20 seconds, 1 minute, 5 minutes, 6 minutes. So this is all possible. And what is the data that you're going to collect within that specified time? First of all, how many vehicles are being detected by your solution, by our sensor or camera. Also the average speed of those vehicles, but also the headway. And what I mean with the headway, that is going to be the distance between nose to nose between two vehicles and measured or presented in meter. Gap time can also be in feet if you're using the imperial system. Then we have the gap time. What is the gap time? That is the time between two vehicles measured from the from the tail to the nose of two vehicles. That's in seconds. What we're also going to measure and we're also going to give is what we call the occupancy. So we know in the detection zone that you have drawn in a particular spot how much, what is the percentage of occupancy of that particular point. And that point will give you the possibility to measure or to give the travel time, because we give you the density. We give you how many vehicles have passed over 1 kilometer on that particular point. So it's a kind of calculation that we give, a calculation that allows you to do travel time. And what we also can do is calculate the average vehicle length. This is a number that is going to be really helpful for classification. And this classification will be based on the length of a vehicle. And you can go up to 5 classes if you want to. And this information will be given to you each time per lane per vehicle class. One thing, there are some limitations to certain solutions. So not all solutions will be able to do all the time 5 classes. During daytime, all of them have no issues of doing 5 classes, and classes that you have set up yourself based on the length of a vehicle. During nighttime, and when I'm talking about nighttime, I'm talking about pitch black. There's no light source whatsoever outside except for headlights or taillights of vehicles. When that's the case, well, thermal cameras, no issue whatsoever. They can do also at nighttime 5 classes. When we're talking about visual sensors, then some sensors can only do 2 classes at nighttime, and then it's based on the headlights. Close to each other is a car, further away is a truck. Or 3 classes, but then we're talking about a little bit more high-end solutions. Then we can also do motorcycles, headlight of a motorcycle, so 3 classes. But let's say thermal, no issue whatsoever, day-night, 5 classes. Visual, daytime, 5 classes, no issue. During nighttime, and it's pitch black, there's no lights whatsoever, then it's 2 or 3 classes. And here is an example of a visual camera that we used. So we have these loops. So the moment a vehicle drives through these loops, we have, it starts to collect data, and we can represent some of the data on display. So you see in the top right corner the zone. So we have 4 zones, the number of vehicles the zone have been counted, and also here the individual speed that we use to make the integrated time, and also the classification. It has now at this moment all class 2. And underneath we have another type of data, which I will explain in a bit. But this is an example of traffic data. The number of vehicles, the number of solutions that is able to collect traffic data is a little bit bigger. First of all, we have the TrafficCam Extreme that is capable of doing that. ThermiCam 2 and ThermiCam are able to do that too. A new one in here is Traffic Radar. That's a hybrid one, can also collect data. These sensors are more used in more urban environments. But traffic data is also something about interurban, highways and bridges. You can use them over there too, but if you want a little bit more detailed information, or you have a higher demand on your data, then you can also go for our FLIR VIP modules. There you need an extra camera, a visual camera or a thermal camera. They can collect data, or an all integrated in one camera, that is the TraffiBot. And then the 2 thermal cameras, either the FLIR ITS AID with just 1 thermal lens, or the FLIR ITS dual AID with 2 lenses, a visual lens and a thermal lens, is also capable of collecting traffic data. Yeah. So these are the traffic data solutions. I just mentioned already, and you saw it already on display, the zones here, they are not only able to collect what we call traffic data, you can also collect what we call flow data. And in some cases, you only want this flow data. What do we mean with flow data? Well, flow data is two types of data. That is flow speed and zone occupancy. Only these two. But these two are quite often used for what we call our queue detection or our levels of service. What we are going to in fact do when we are able to collect the zone occupancy and also the speed, and the system has, in this case, a default setup threshold of 20%. Any traffic, whatever speed, and the occupancy is less than 20%, we call the traffic at that moment normal traffic. Is that threshold of 20% exceeded on the occupancy level? Well, then we check the speed. Is the speed still above 60 km per hour? We don't call the traffic anymore normal. No, it's level 1 or dense. And we can continue, still above 20%, but speed drops between 60 and 40. Well, we have level 2, between 40 and 20 km per hour, 3, and so on, 4. So 4 levels of service going from dense, delayed, congested to stop and go. This is what we call the flow data. And in some situations you prefer more this information, or you only want to use that information and not the more detailed traffic data. And which products use that? Well, it's the same one as traffic data. So exactly the same sensors are capable of doing exactly the same data. One nice thing is when we're talking about traffic data, on this traffic data, then we are quite specific and really quite demanding on the angle of detection. There the angle should be at 45 degrees. Traffic data is a little bit less restrictive. So you can even do it on an angle of 80 degrees. You can collect quite some good flow data on that point. Yep. Then, still within the architecture of collecting data and sending it over API towards any kind of server, laptop, or recording device, if you could call it a collection device. We have one that is quite new, and maybe some of you don't know it yet, and that is what we call premium traffic data. And what is so premium about it? Well, it answers to 2 questions from some of our customers. Some of our customers want to detect either at intersections, wanted to get more information. So at this moment, at an intersection at the stop bar, you can do a vehicle count, but that's using pulses, or they use the vehicle presence data, but that's only a count, and that's only zone occupancy. The downside when you do that at the stop bar is that the traffic is always interrupted. And for data, the ideal way of collecting data is that you can do it on free-flowing data. Even if it's slowing down due to a queue or whatever, it started with free-flowing. Where at stop bars, the thing is, it's always stop and go. It's called, that's why it's called a stop bar. So you have that stop issue. Customers say, I want to have a little bit more accurate data. I want to know, for instance, I want to do, let's say, classification at my stop bar. Until now, it's not possible, except now with the premium traffic data. So that was one of the reasons. A second thing behind that premium traffic data, and that's a little bit more when you have more free flow, we have areas, countries, where lane discipline is a little bit an issue, or where the number of vehicles that you want to detect, or in fact, the type of vehicle you want to detect, a motorcycle, it doesn't stick to a lane. It drives wherever it can drive, and then it was quite difficult to capture or to count them if they're not driving in the designated detection lane. And so with premium traffic data, we don't have that issue. And best way to show it was this following example. So what we have here, we have an area where we're looking at, and the moment that in fact a vehicle crosses the line below, there we have an accurate count. So although that you see these loops out there, they will still be helpful, but the major part of the data comes from what we see crossing over the line. And using that line plus the data from the loops gives us a more accurate data than with the normal traffic data loops. Now, which solutions are able to do so? That's possible with a Thermicam and a Thermicam 2. So these two can do so. So this is the overview of all the types of data that we can collect, that we can present with our architecture, within our architecture or collection architecture. Before I continue and discuss more in detail the last one on the connected architecture, I'm going to check if some questions already popped up. Now I want to go to the next architecture, is in fact the architecture about what I call the connected. And we call this type of data high resolution real-time traffic information. So in this case, what we have out there is that we have in multiple locations in our city, in our region, we have devices that foremost capture through Wi-Fi information of the vehicles passing by, because we're capturing the Wi-Fi from these vehicles, or even pedestrians, or even cyclists. We collect that information, we send it to a cloud, and within the cloud we have quite some algorithms doing quite some job, and that allows us to know more about what is happening between these points of collection. If I put it to a different type of drawing, so we have, for instance, here an intersection. We have at an intersection at our post where do you have a traffic light, there is our sensor that's capturing that Wi-Fi, and in like an area of 100 meters, we're capturing that information. It would look something like this. So this would be our intersection. So the moment that a vehicle is passing by, we capture the MAC address of a passing vehicle. It's about 40% of these vehicles that we capture. We hash that information and we send that to the cloud. So if I put it then, let's say we have two intersections. So that allows us, with the information of these two intersections, that would allow me, for instance, very simple to know, okay, what is the free flow speed between a vehicle exiting the first intersection and entering or arriving at the second one. Not only that, also for the stop bar travel time from stop bar to stop bar. Or what was the total travel time from one intersection to another intersection with the delays in between. And that's, the simple things. But it's not only that, it's also what I just said about high resolution, because it's also possible that we use the point data. If one of the sensors that I discussed in the previous architecture is there, it's also put onto the cloud network with the Wi-Fi, putting it together, well, it will give you quite some rich information, putting it into the cloud. And I will just give you a short preview of how it would look in the cloud. Will not be able to go into detail because otherwise I'm going to run quite big time over time. But I will show you how it looks. I hope that you can see the browser. So I will go to one of the sites that I have access to and I can show you. So this is our test site here in Kortrijk, yeah. So there are our sensors. So I will take one of the sensors out there. Let's take that one. So this sensor has, in fact, it's a double one in a way that it's capturing the Wi-Fi, but it's also able to collect data through its lens. And you can see it here because it's a thermal camera. It's also a Thermicam 2, if I'm not mistaken. And if I want to, I can get from that, I could say, okay, and I hope I have some information here. So here it says, okay, that is, now looking at it, that is the data resolution of it. Let's check something else. What is the speeds that that device measured? And this is now just for one camera. Of course, the most interesting part, if that camera would be on a road, multiple cameras, I made a route in between these cameras, and then I could really measure the travel time between these points and also the delays in between these points. At the moment, I don't have one that I can just show you here, but that's how it works with our high resolution data on that point. Now, which devices are collecting that information? That is at this moment possible with the Trafi 1. That one has the Wi-Fi capture on it. It's also possible that you say, no, I don't need a camera, but I just want to grab the data. It's possible with the ITS IQS, so that's a sensor, only Wi-Fi. And then we have the Thermicam 2, will have also an antenna able to collect that data. So that's also possible with these devices. So on that note, I would like to end this presentation on traffic data. Good. If no further questions from your part, I do thank you all for joining me in this webinar. I hope you enjoyed it as much as I did. Anyway, thank you very much for being here, and I wish you a very good day, and see you next time.